Hello everyone, welcome to series lectures of basic electronics. I hope you have seen my last lecture, which is based on bridge rectifier along with filter. If not, then you can click on this I button. So let us discuss about today's lecture. In today's lecture, we are going to discuss about clamper circuit and voltage multiplier circuits. So what is clamper? Let us start with basic idea of clamper. Clamper is used to clamp the input signal to a different DC level. In this circuit diagram, we are going to use DC supply and capacitor. So here, clamper adds a DC voltage to the signal. DC is a constant signal. It adds this signal into the final output waveform. Clamping level is decided by the capacitor used in circuit diagram, because there are different types of clampers are present here. Number one, you can see positive clamper, and number two, negative clamper. So let us discuss about waveform. If you entered input waveform, then after your clamper is behaved as that circuit. If there is positive circuit, positive clamper, then your waveform clamps off or shift positive side. If there is a negative clamper, your waveform shift down, that means negative side. So here let us discuss about waveform. This is the input waveform, and this one is the maximum voltage of input waveform, which is called as Vmax. So if we entered this input waveform, finally you will get this type of waveform. That means this waveform is shifted positive side. So this one is Vmax, and its maximum value is known as 2 Vmax. So this is known as positive clamper. If there is a negative clamper, then your waveform shifted downward side. Here we can see it is negative clamper. Here where the waveform is started is minus Vmax, and maximum value of this waveform is known as minus twice Vmax. Here we can see this is the minus twice Vmax. So in this lecture we are discussing about positive clamper. So let us start with positive clamper. So here we can see this is the circuit diagram of positive clamper. In this circuit diagram, diode's direction is upward direction, and we include diode with capacitor. So this is known as clamper. In this circuit diagram, we can see this is the positive clamper circuit. That means our final output voltage shifted positive side. So let us discuss about cases. We entered here input waveform, which is in the form of positive half cycle and negative half cycle. So first you have to take negative half cycle. Remember this, you have to close circuited this diode first. So we are going to use here negative half cycle, right? So if there is a negative half cycle, the diode acts as a closed loop and charges the capacitor up to the Vm. In this circuit diagram, capacitor charges up to the Vi, or we can say Vm. So basically Vm is equal to Vi. In this circuit diagram, diode is working in forward bias. That's why it becomes closed loop. So the output voltage will be 0, because current always flowing from this side. Here we can see current is flowing from low resistance. There is a one resistor is connected across the diode. So here we can see in this equivalent circuit, the current flowing from plus to minus direction. So we cannot get output voltage across this terminal. So it becomes 0. So remember this is the case number 1. Because finally we will design a output waveform case number 2. For positive half cycle, if we apply positive half cycle, diode becomes reverse biased. So it is open circuited. So when diode becomes open circuited, that means we will get output voltage across the resistor. So VO will be fine. Remember this thing here, capacitor is charging. Here capacitor is charging, so here plus sign and this side minus sign. Always capacitor discharging from this side, plus to minus, right? So in first case current is flowing from in this manner. So first terminal of capacitor is this, so it becomes positive and other terminal is becomes negative. Here capacitor is charging. In case number 2, capacitor is actually discharging across this RL, or we can say resistor, because we will get output voltage across this terminal. Now how we get VO in case number 2? Before that we have to apply KVL for this circuit diagram. So I am starting with VI and going towards output voltage VO. VI is, its sign is positive, so it goes to the VM, but VM's first sign is negative. So we put here VI plus VM, then it goes to the VO side, but VO's first sign is positive, so we put here minus VO is equal to 0. Finally, our KVL equation is VI plus VM minus VO is equal to 0. Now we have to find output voltage across this resistor, so we can make common VO, which becomes VO is equal to VI plus VM. Now we are going to put different values of VI in this equation and we will get output voltage value. Number 1, first, if here VI's value is equal to 0, then what happened? If VI is equal to 0, then VO is equal to 0 plus VM. 0 plus VM, that means your final output voltage will be VM. So here we can see VO is equal to VM voltage in number 1. Number 2, if VI is equal to VM, both are same. VI is equal to VM. If VI is equal to 5, that means VM is equal to 5. So capacitor charges up to maximum voltage. So if VI is equal to VM, then VO is equal to VM plus VM. So it becomes VO is equal to twice VM. So here we will find twice VM in case number 2. Now 3. For VI is equal to, because this is the AC waveform, here we can see this is the AC waveform. So at this time your waveform goes down. So we can take VI is equal to minus VM. So VO is equal to minus VM plus VM. So it becomes VO is equal to 0. So like this, according to KVL, we can apply here different values of VI in this equation and we will find this output voltage VO across this resistance. So let us discuss about these 3 cases. VI is equal to 0 at this time, VO is equal to VM. Number 2, VI is equal to VM at this time, VO is equal to twice VM. And in third case, VI is equal to minus VM. In this case, VO is equal to 0. So in this waveform, we can put that 3 different values. So in first, we will enter input value. According to this input, we will get output voltage. So here, if your VI is equal to 0, at this time, your output voltage is equal to maximum. Like this, in case number 1, VI is equal to 0, at this time, we will find VO is equal to maximum voltage, VM. Now case number 2, your input is maximum voltage, then your output will be twice Vm. If you enter 5 volt, your output will be 10 volt, twice your input value. So here in this case, we have seen Vo is equal to twice Vm because of here you enter input voltage, Vi is equal to Vm. Right? So here twice Vm, your case number 2. Now in last case, here if your negative input is applied to your circuit diagram, at this time you will get your output is equal to 0. Why 0? Because here we can see Vi is equal to minus Vm. At this time Vo is equal to minus Vm plus Vm, and then it becomes Vo is equal to 0. So your output voltage becomes 0. Here like this we will get waveform of input and output clamper. So this is the clamper circuit, or basically here we can see this waveform is shifted positive side, so it becomes positive clamper. Similarly, we can solve negative clamper with the diode direction making downward side. So that becomes negative clamper and your waveform shifted in negative side. So this is the clamper. Now next, let us discuss about new topic, voltage multiplier circuit. So at the output side of rectifier with filter, we will get maximum output voltage of Vn. But by using multiplier circuit, we will get higher voltage than Vn. It may be twice Vm, thrice Vm and 4 Vm, to keeping transformer turns ratio unchanged. Voltage multiplier is an electrical circuit that converts AC electrical power from lower voltage to higher voltage. That means if you entered Vm, then you will get twice Vm. If you entered 5 voltage in input side, then you will get 10 voltage, 15 voltage or 20 voltage. So basically voltage multiplier is classified into two types. Here we can see number 1, half wave voltage multiplier circuit, and number 2, full wave voltage multiplier circuit. So in this lecture we are going to discuss about only half wave voltage multiplier circuit. So let us discuss about half wave voltage doubler circuit. It is known as voltage doubler because it doubles the input waveform. So here we can see this is the circuit diagram of voltage doubler. It is the clamper. Now here let us discuss about its operation. Here remember this circuit diagram. We are entering positive half wave and negative half wave cycle to this circuit diagram, and then after we will get output voltage across this capacitor. Remember this thing, here we are not connecting load resistor RL. Why? I am going to discuss it at the end. So let us discuss about for first operation for the positive half cycle of input. If we enter positive half cycle, then your capacitor C1, here we can see capacitor C1 because current always flowing from plus to minus from this direction. So your capacitor C1 will be charged. Then after one node is coming. At this node, your current is divided into two parts. One current is flowing from downward to the diode D1 side and another current flowing from diode D2 side. So due to this, your diode D2 becomes reverse biased. That means it will be in open circuited. And your diode D1 becomes in forward bias. That means it works as a forward bias. That means closed circuited. So always your current flowing from diode D1 to minus. So here diode D2 becomes open circuited, so current not flowing to the output side, or we can say capacitor C2 side. So here we can see diode D2 is reverse bias, so C2 is isolates from C1. So that means your C1 becomes charged up to Vm voltage. Vm, that means your maximum input value, because we have discussed in clamper Vm is equal to Vm. So let us discuss about for negative half cycle. If you entered negative half cycle, then your capacitor C2 is charged. Now here in this circuit diagram, current is flowing from below to above, because for negative half cycle here it becomes positive, this terminal becomes positive and above terminal becomes negative. So current always flowing from lower side to upper side. So your diode D1 becomes reverse biased. Then after current flowing from C2 side, that means your capacitor C2 becomes charged, and current flowing from D2 side, then your diode D2 works in forward bias. That means it works in closed circuited and goes to the minus terminal. So due to this operation, your C2 charged up to Vm side. Here we can see if in the next positive half cycle both diode discharge if no load connected across the C2. So we will get V output. Your final output voltage becomes Vm, which is already charged in positive half cycle across this capacitor C1, and V2, which is across this capacitor C2. This is also Vm, and final V output is equal to Vm plus Vm. That means your final output voltage across this terminal is equal to twice Vm. So for this method you will get twice Vm. Now here one question may be raised, that why we are not connecting RL or load resistor across this terminal, because if we connect here RL, so your capacitor C1 charges will be discharged to this resistor. So we have to hold capacitor C1 charge. That's why we are not going to use here load resistors RL. From this process we can get double output. So this is the doubler. Now types of different voltage multipliers. There are various types of voltage multiplier. We have seen half wave. Similarly, we can see full wave voltage doubler. So in this circuit diagram, we will also get twice Vm at the output side. Then after number 2, voltage tripler circuit. Here we can see if we are going to add one extra diode. So due to this adding process, we will get extra thrice Vm. So your input side, if you enter 5 volt, then after your output side you will get 15 volt in tripler circuit. So that means you can make n fold voltage multiplier by adding diode like this manner. So this is the voltage tripler circuit, and similarly you can make voltage quadrupler circuit. That means you will get 4 times Vm at your output side. That's all for today's lecture. In this lecture we have discussed about clamper circuit and voltage multiplier circuit, which is most important topic. So if you have any queries related to this topic, you can mail me on this email address. And for that, I have given you few assignments related to this topic. You can find it in description link. That's all for today's lecture. Keep reading, keep learning. We will see you soon in next coming lecture. Thank you.